For Batterywala, who's a performance architect at Impetus Technologies. Mr. Batterywala is an experienced delivery-focused technology specialist with close to 10 years of development and testing experience. He is currently working as a lead performance engineer with Center of Performance Engineering Excellence at Impetus Technologies. Today, he's going to talk on cloud-based performance testing. Please come in, sir.
Hi, good evening, everyone. So it has been a long day, I know, and we have been having so much of good presentation. So I hope that I would end the day on a similar note. So this topic, this is cloud-based performance testing. So let's quickly see what I want to. So this is the outline that I thought I could share. So just wanted to focus that how the advent of cloud has changed the arena of performance testing, and how can we leverage cloud to do more efficient, more cost effective performance testing, and even we can test those scenarios that were not possible to test with an earlier traditional model, which is on premise. So we have already in earlier presentations we have looked at that what are the certain key drivers that are pushing us towards cloud, pushing enterprise towards cloud. So there has been internet growth, people are using internet from the smartphones, from the laptops, broadbands are getting popular. So data is increasing, we are getting into big data, and to address all these limitations, enterprise applications and even common applications are moving to cloud so that they can be accessed by more and more users. Now on the one hand it's really good, but on the other hand it presents challenge to all the architects, performance engineers, that once the applications are designed to be so scalable, used by thousands and thousands of users, so how they would be tested? So we have seen some applications, some case studies being shared, but how to test those applications, it's a challenge in itself. And with the traditional model, let's see. So traditional model that we are calling it as on-premise, because it has been conducted in the internet of the application developer. So all the components, the application under test and the performance testing infrastructure, they are all deployed in the on-premise. Now this presents lots of issues. So one of the major issues is procuring the hardware. So imagine that if you want to test an application with, let's say, 10,000 concurrent users, so the kind of load generators, the kind of agents that you would require, they would run into tens of machines, and the kind of data they would produce and the analysis that has to be done. So all these hardware has to be procured. Now once we need to procure the hardware, it doesn't alone come, it comes with the software. There has to be administrators who can maintain those, and since these hardware procurement is a costly thing, normally these environments has to be shared across the teams. So we very well see that performance testing team doesn't get a shared a dedicated environment for testing. They share it with QA teams, they share it with staging, they share it with UAT. So because they cannot afford a dedicated environment. Then the other problem could be we start testing with low number of users, we could have some number of machines, as in when we scale, the number and nature of machines could differ. So let's say some of the machines could be 2 GB machines, some of the machines could be 4 GB, some Windows, some Linux. So there is a difference the way load generators are there, and each machine can then react differently. So load generators are not optimized. The other thing is, now since most applications are moving to cloud, so they would be accessed by the end user. So the traffic would come through over the internet, through routers, through DNS, through firewalls. When we are testing such applications in the premise, so we are all ignoring such things and we are directly testing the application. So though it would give us some numbers, it would give us the real performance, but would it be end user experience? No. To test the end user experience, we need to test it from the end user's perspective. So we need to go out and hit our applications. And the other thing is unexpected search. So again, we saw earlier that for a small window, we cannot invest such a huge infrastructure to test. So though a peak is just 6 to 8 hours or let's say some days, So typically we have seen e-commerce websites, so they have peak load just before the holiday seasons where lots of sales starts. So the company cannot invest in test infrastructure for only that duration. So we need to have an environment which can be set up on demand. So these all limitations ideally point us to using cloud. So the answer to this question is using cloud. Now let's see what is this cloud based performance testing. So as the name suggests, we conduct tests from the cloud. So no investment in infrastructure, everything is provision. When you need it, the moment you need it, how many things you need, just you use the APIs, provision the infrastructure on the cloud and start using it. So advantages: affordable, cost effective, pay as you go. You need to test 500 users, you need one machine. You need to test 10,000 users, you can use 10 machines. So there is no need to invest in the hardware. The other thing is license cost of the tools. So there is no need to have a single tool. You can have different solutions depending on your requirements, and you can scale your solution. So working for 500, working for 10,000, even we have seen applications being tested with 100,000, 200,000 users. So all this is possible because of the availability of cloud. And then other thing is realistic conditions. So when you are developing an enterprise application, let's say it would be accessed from different parts of the geography. So in US, let's say people from East, from India, from Singapore, everybody would start using it. We need to know that when you are deployed in some region, so what is the experience of people accessing it remotely? So people close to that region would have a good performance, but what about, let's say, something deployed in US, if from India it gets hit, so what would be the impact? So we need to test it. So the cloud provides us the benefit of testing such things, and also the all other components that constitute the delivery chain. Your CDN networks, DNS, firewalls, all comes into picture when your test starts actually from your remote locations or via the firewall. So, but there are few challenges as well when we talk about cloud. So it doesn't come with all the advantages. There are challenges, and one of the most important challenges is data security. Now, when you are testing your applications from outside, all your data, everything is going over the internet. So it might be possible the test results, the test assets, they are all stored on cloud. So how do we make it secure so that they are not misused? Then let's say if you want to test applications that is there in a controlled environment. So how can we test it? It is not accessible publicly. So we need to find some ways so that these can be addressed. The other thing is repeatability of tests, consistency. Since these tests are run over the internet, so a major impact is done by the available bandwidth, and it can vary depending on the usage at that particular time. The other thing is identifying bottlenecks. Now, since the tests are not repeatable, so if your point is that, let's say we have an application stack and we want to see how it behaves with some number of users and we want to identify the bottlenecks. So bottlenecks may be with your app server, DB server. When you are testing it from the cloud, the test results may vary. So if you have made some tuning changes, if you have made some code changes, it would be very difficult to say that, okay, since you made some tuning, your results have improved, because it might be due to the network condition as well. The other thing is monitoring. So we need to have, when applications are deployed in-house, it is very easy to monitor them. There can be lots of tools. Once you go out, then again you have to set all your firewall policies, you have to provide appropriate access so that all these things can be monitored: CPU, memory, network usage, all these things. So let's see what are the kind of cloud solutions that are available. Now, depending on advantages, challenges, there are different models that people have come up with that help in addressing these solutions. Now, one of the most prominent solution is moving the tools on the cloud. So there are lots of existing tools, JMeter, Grinder, Load Runner, you name, there are lots of such tools. So simplistic way would be you take this tool and you create an instance on any cloud provider, install these tools there, and you have a tool on the cloud. But is this the correct way or is the best possible way? So we will see. Then there are some that uses the automated provisioning. So by automated provisioning we mean the elasticity. As in when you need the load generators, you can spawn those and you can run your test. And then since each one of these has their own pros and cons, there has been a third way, a hybrid solution. So you use benefits of on-premise, but you also have the elasticity in the cloud. And then based on our work that we have done, we have come up with our own recommendations that tries to minimize the disadvantages of each of these. So let's see the first one. So this is the first one where what you do is that you move the entire tool on the cloud. So typically a performance testing tool would have a recorder that is used to create test scripts. It would have a controller that would govern all your test execution, and there would be agent machines. So we call it kind of load generators. So in the first way, what we do, we install the tool as it is on the cloud. So user access the cloud, use the tool, create the test scripts and run the test. So this is what it looks like. Now it has few advantages and disadvantages. So one of the prominent advantages, tool familiarity. There is no need to learn any new tool. So this tool could be JMeter, Grinder, LoadRunner, which we have been using for a long time. So nothing changes. Just install the tool and use it. The other thing is script reusability. Suppose you had used that tool, you already had scripts, so no need to record new scripts. So you save time on that. You just port that and start using it. But what are the disadvantages? Now one of the prominent one is a user has to know how to use cloud, because these doesn't provide any web-based access, any portal access to the solution. It is all done via RDP or SSH. So the teams have to have accounts to different cloud providers. They need to know how to create image, how to create instances, how to install the tools, and then only they can use it. The other disadvantage is, suppose we want to use this solution to run a large scale test. It's at thousands and thousands of users. So we may need to have multiple such instances. So one has to manually configure those instances, which again takes time, or one has to write, even automate scripts. So they have to invest efforts in automating the scripts, creating those, and then manually automating the entire scenarios. And the other thing is test asset management. Once we have run the test, we have got the results, now these instances are no longer of use. So what we do, we shut them down, we terminate it. Once we terminate it, we lost all our entire data. So we need to have our test data management strategy that okay, whatever results we have gone, we take it into our local machines, we save it for our future references. So in order to address these, what we have gone is, there is a second type of solutions which we call it as a cloud provisioned solutions. Again, what it does, everything remains on the cloud, but rather than a physical access to the machines, they provide a cloud portal. So you can have a web-based access, so you can access it from your desktops, iPads, mobiles, and this provides all the configuration, all the basic features, so that you can configure a test that okay, I want to run a test with these many users across these regions, and the tool would automatically provision load generators on different regions and it would test your application. But again, there are a few limitations of this as well. So some of the advantages is on-demand performance testing. Whenever you want to run a test, you log in, you start a test and you run it. So you would be charged only for the duration of your test. So no need to license a software, no need to get any hardware. So it's really very cheap. Since it provides a web interface, it's really usable. No need to learn any tool, no need for physical access, no VPN, no VNC, nothing. It can be accessed from anytime, anywhere. You can run your test anytime, you can access it from your home, from your office, from your mobile. So this is well suited for cloud based applications, mobile applications that scales very quickly. So when you are developing a mobile application, you never know, it gets accepted and suddenly your user base increases from hundreds to thousands. So this is very useful for those cases. But there are few limitations here as well. Data security. So as a testing team, you do not have access to your test data. It's all there on the cloud with a provider. So how would you use that? How would you make sure that your request responses, your test results are not misused? And then again, since your tests are running over the internet, they are not consistent. So network latency comes into picture. So this cannot be used for bottleneck identification. You won't be sure that whether my code is a problem or network is a problem. So addressing these two models, there has been a third one, which is a hybrid solution. Now hybrid solution, what it does is that it has recorder and controller on the premise. So you have a subset of your tool on the premise, so it helps you to keep all your test results under your control. So your test results doesn't go out, they are on your premise itself. Since your controller is on premise, you can monitor your application easily because they are all in the same network. And you can, the only way you use this load generation, when you want to, let's say, run some large concurrency tests. So these controller provides provision, so you configure that okay, you want to use load generators on the cloud, and then it generates a load. So for some concurrency, let's say 100, 200 users, you can use the on-premise, and whenever you want to scale, you use the cloud-based load generators and run your tests. So this is again a hybrid solution. So again, what are the disadvantages? Now, one of the disadvantages that it is having is the controller is still a physical component. So you need to have physical access to that machine. So if you want to run your test from anywhere else, you need a VPN connection, you need a remote desktop, you need a PuTTY to connect to this machine. The other thing is, since this is a controller recorder you have, so it has a huge license cost as well associated with it, because the tool gets installed in your environment. So there is some licensing cost associated. It also provides script usability, because once you provide script here, you can use the same script and you can scale it with number of users. And then since your controller is here, you can have all your monitoring and diagnostic capabilities. So you can monitor easily the resource statistics for each of those servers, because again they are in the same network. So what we have seen is that based on this, we analyze that we can use either of these, but each one of these has their own limitations, own advantages. So what we did, we came up with our own recommendation, which we call it as a two-phase approach. So what we say is that neither cloud can be avoided nor on-premise can be avoided. A strategy has to include mix of both. So we need to use on-premise where it is more advantageous, and we need to use cloud where it is more advantageous. So on-premise we see is that it's more suited for low concurrency tests, for limited scalability, and mostly for diagnostics and bottleneck identification. So during early stages of application development, when the application is still not ready for scalability testing, it is still not ready to be exposed to public, we can use the on-premise methodology, where we have the tool, we develop the test assets, run some sanity and baseline tests, and we provide system tuning, environment tuning. Since the environment is under a control, it gives us a tremendous control, and we can measure any parameter changes that leads to performance improvement. And we go to the cloud when your application is ready for production, for staging. So it's now you start scalability testing. So what you do is that you take your application, deploy, and you use the same scripts but run your tests from the cloud. So it gives you the advantage of elasticity, scalability on demand, where you run lots of tests from the cloud, but only when your application is ready for that. So that's what we already covered. So specific places where we can use on-premise. So another thing is, since during the early stages of development where we need to create test scripts, so it is very easy for teams to create test scripts when tools are installed in their local environment. So they can create against their local deployments, against their QA deployments, they can parameterize it, they can create their verification criteria. So it is very easy for them to create the test scripts, and then once we are ready that okay, we have run few 550 users tests, 100 users tests, we are sure our script scales well, and now we are ready to run the 1000 user test. So these are some best practices that we have come up with. So the communication, so this refers to the communication between the load generator and the controller. So typically load generator would get all your test results, would send it to the controller. So what we recommend that even that communication should be encrypted, because when your load generators are outside your firewall and they are communicating with your controllers, so there is no chance that somebody can trap that data and try to misuse that. The other thing is load generators. So load generators are mostly the commodity machines that we use, and their basic purpose is just generating the load onto the target application. No other applications are running, no other services are running. So they can be optimized, they can be provided higher memory sizes, they can be, the number of sockets can be increased, so these things can be done. Then we should always try to use automated provisioning, because it saves time, and also it makes sure that all our load generators, all our test infrastructure is consistent. So most of the providers, cloud providers, what they provide is the creation of images. So you install the tool on one machine, you create an image, you optimize it, and now you have this image ready. So whenever you want to scale your test, you just use this image, create more number of instances, and you can run your test. The other thing is that you should try to use an integrated solution. So that is solution that works both on the cloud and on premise. So what it does is that it provides script usability, and it also reduces the learning curve for the team. Else there could be a one tool, one set of scripts which we need to use for on-premise, then there could be other scripts, other set of tools on the cloud. So we should try and avoid that. And other thing is support for multiple clouds. So that is another important thing. When you are trying to test our application, we should try to use it, test it from multiple cloud providers. So Amazon, let's say, would cover some of the geographies, Azure could cover some, Rackspace, Terramark. So we should try to get a solution that works on each of these, so that we come to know that okay, from these geographies this is the performance. And even let's say if our application is hosted on Amazon, so we would definitely like to test that application from a different cloud provider, because again when we try and test it from Amazon, it could be a single network. So based on that, what we have done is we have created a kind of checklist. So that shows that in which situation we can use which kind of solution. So there are a few attributes that we talked about: tool familiarity, script usability. So it shows that kind of tool familiarity, we use all on-premise tools on the cloud, or repeatability of test. So it's always on-premise model which would be repeatable. The bottleneck identification, we should go for on-premise. So one of the benefits of this cloud provisioning in this is you can run multiple tests in parallel. So since there are no licenses involved, nothing, you can run multiple tests. So based on that, what we have done is that we have tried to create a solution for performance testing from the cloud that we call it Sandstorm. So we used it in one of our assignments, which was the e-commerce application, and the problem was very much the same, that the application was supposed to handle lots of users for a certain period of time. So we implemented the two-phase approach that we talked about. So we started with on-premise during the early development phases. We tested it, removed the bottlenecks, and then when it was ready for production deployment, we used the cloud and tested it. So these are some of the screenshots, but they are not clear, I think. So this is what at the end, like to sum up, that the effective performance testing strategy involves both on-premise and on-cloud models. We cannot live with either of these, and this is what we can come up, that when we should use cloud enabled and when we should use an on-premise. So if it's an internet mobile cloud application, it is better suited for a cloud application. But if we want to start performance testing early, we want to do performance tuning, diagnostics, then on-premise is a better candidate. For high scalability testing, user experience testing, again we should go for cloud. And then cost effectiveness. So yeah, cloud is much more cost effective than the on-premise testing. So that's all I had. Any questions any one of you have? So in case you have any queries, feel free to write to me at my email address. I'll be happy to respond it. So
Mr. Batterywala, so we on behalf of UBM would now like to give Mr. Batterywala a small memento as a token of appreciation. Thanks so much. So that ends day one of Cloud Connect 2012. We really would like to thank all our attendees and speakers for making it a wonderful session of knowledge sharing. Hope to see you tomorrow again. So the keynote will start at hall number 1, and following that we'll have the session starting here at hall number 3. Thank you so much.